Okay. The next thing we're going to look at is the induced field, charging by induction. So you know about static charges and how they are created due to friction. So that you know, like when you rub a rod and by a woolen cloth, one gets a positive charge, the other gets a negative charge. So that is static electricity developed by friction. Then there is induction. In O level, you would have learned that if there is a there's the picture. If there is a positive sphere and you bring a negatively charged rod closer to the sphere, then the positive charges will come towards it and the negative charges in the sphere will move away from it. So be careful. If you are having 5 charges here, then 5 should be here, 5 should be here. More importantly, here if this is 5 positive charges, then there should be 5 negative charges, even if not equal to the same number in the rod, but here it should be same. So what happens is, when a force is brought in, what happens, there's a beautiful word in the textbook, they call it the redistribution of charges. The charges in the sphere which were distributed everywhere, the 5 positive and the 5 negative, which are distributed everywhere, now they are redistributed such that the positive falls on one side and negative falls on the other side. In O level, you would have explained this as the negative charges are attracting the positive charges, negative charges are repelling the electrons on this side, and the electrons move to the other side. But no longer talking in terms of positive charges attracting negative charges, or just talking in terms of charges is not very good and sometimes not given marks. You have to talk in terms of the field lines. So what happens is, when you bring a positive charge, the negative charges will move towards the positive charge. Now this is how you used to say. In O level, you used to say that when you bring a positive charge, the electrons, the negative charges, used to move towards the positive charge and accumulate on this side. This is how you word the concept in O level. But when you come to A level, how you have to word it is, as soon as a charged body is placed near the conductor, the electric field of the charged body causes electrons in the conductor. So you have to say that when you bring a positive charge, you are bringing the electric field closer to the conductor, right? So when you bring a positive charge, the positive charge has an electric field, and the electric field denotes the direction in which a positive test charge is going to move. Now that means this is the direction, the conductor is here, the positive charges in the conductor will experience a force in this direction, which means the negative charges will experience a force in the opposite direction and they will move towards this side. So you should not say anymore like the negative charges are attracted towards the positive charges. You have to say in terms of the field. The electric field of the positive charge will cause the electrons, the negative charge, to move towards the left side. Okay? And when that happens, something beautiful starts happening inside the conductor. Now originally, inside a metal conductor, the field is zero because the electrons are free to move, so they will distribute themselves everywhere equally. So if you put inside a conductor some electrons at one place, then that electrons will spread everywhere and they achieve a balance, so that inside, if you put a positive charge, that positive charge or any other charge will not experience any force, because the charges given to a conductor are free to move, the electrons are free to move, hence they will flow and achieve an equilibrium or a balanced state. where the forces are balanced. So usually, unless there is a external voltage and external EMF, the electric field inside a conductor is zero. But when you bring a positive charge, the negative charges experience the force in this direction due to the field, and they accumulate here, and the positive charges are situated here. Now what happens is, and inside the conductor, another field, the blue color field, is formed from the positive charges to the negative charges, right? Once the field strength inside the conductor formed by the separation of the charges equals the field strength of the positive charge which is outside. So once the blue field lines become strong enough as the red field line, then further any more redistribution, there will be no more movement of the electrons. Okay, the electrons will, it's like the field is a force, right? It shows the direction of the force. So when there are two equal and opposite forces, they will cancel off, and if you place the positive charge in that place, it will not move in any direction. It will not experience the force in any direction. So this charging by induction you have studied in O level, but when you should be able to explain it in terms of electric field, and you should be able to explain that due to the redistribution, the separation of the charges, another electric field is set up inside the conductor. Okay, now charging by induction, this is common O level thing. When you bring a positive charge, this comes up, then you earth it. Now be careful, the positive charges will not move to the earth because the positive charges are immovable, they are the nucleus. Rather, the electrons from the earth move to the sphere and neutralize the positive charge. If it is the other way around, the electrons, if let's say that we brought a negative rod, then the electrons would have moved here and there would be positive charges. In that case, if you connect it to the earth, then the electrons will be able to move to the earth. So remember that it is only the negative charges which are able to move, the electrons. So if you connect it to the earth, the positive won't move to the earth, rather the negative charges, electrons from the earth, will move here and neutralize the sphere. Then afterwards, if you take the rod away, the electrons will spread uniformly across the sphere and you will have a charged sphere.